Welcome back, boys and girls, to the mathcenter.com. I think this is video number, let me see, 1, 2, 3, 4. This is the 5th video in a series of very short questions taken from one of the endorsed Cambridge textbooks. I think it's Oxford. It's the orange textbook that I use, that I picked to show you some simple questions on indices and surds. This particular question here was asked by one of my year 10 students who studies Add Maths with me online. So I thought that it was pretty interesting because it involves a little bit of logical thinking, some thinking skills, and combined with using Pythagoras Theorem, as well as practicing of how to rationalize surds. So I thought that I should make a video here and share with you, and also to help my young student Navin. Okay, Navin, this is for you. Okay, now if you like what we do, please do follow us on our Facebook fan page, on Google, on YouTube. We've got tons of videos there, and also we've got tons of exam solutions and lots of very good courses that we've done, especially following the new syllabus, the year 2020 syllabus for Cambridge. Do subscribe and you will not regret it. Okay, so let's not waste time, let's begin. This question reads, okay, we are given two congruent rectangles. Congruent means a same size, same shape. Okay, rectangle A and B. The lengths are given 3 plus square root 2, and the width is 5 minus 2 root 2. These two congruent rectangles, the rectangles are cut into two triangles, all right? Then they are arranged into 4 to form a square. So let's say I marked it, this is A and this is B, right? Let's say this is C and this is D. C and D. So logically speaking, you can see that this is the hypotenuse, will be this part here. All the 4 hypotenuse are arranged in such a way to form a square. So the square is actually, the length of this square is actually the hypotenuse. Okay, now people, if you hear some snoring in the background, do excuse me, because my dog, my pet, he's next to me, and he's a real mommy's boy. He follows me everywhere. So do excuse me. Maybe in the next video, show you a picture of what he looks like. Okay, so now the first question, so you have wrapped your head around, therefore this must be 3 plus root 2, right? This must be 3 plus root 2, and this must have been 3 minus 2 root 2. So again, you take a look. So how do you find this side? Let's call this X. The inner circle here is called X. X is actually the longer length minus the width. Okay, that's how you find X. So find the area of the central square. The area of the central square will be X times X. The length of X, people, I repeat, this length of X is actually the whole length minus the width. Okay. Okay, so I repeat again. I think this is where some of you stumble to find. Okay, you can let's begin by looking at my answer. Okay, I think my drawing will be a bit clearer. Okay, this is my beautiful drawing. Can you see? So to find the area of the small square, which is why I shaded in red here, will be X times X, right? So X is the longer length. This length here is same as this, right? And this is 5 minus 2 root 2, which is this. See? So therefore X is actually the longer length, 3 plus root 2, minus the net answer of 5 minus 2 root 2. That's what I've written here. Okay, slowly, people, very carefully. Okay, follow the logical thinking you must know. So 3 minus 5 is negative 2. Root 2 minus 2 root 2 will be 3 root 2. So you have 3 root 2 minus 2. Okay, you can leave your answer in surds, that's fine. You don't have to use the 2.24 units. So an exam question, if they're silent, you can use either. If they say simplify it exact value, then you will have to use 3 root 2 minus 2 units. Okay? So the area of the square will be 3 root 2 minus 2 multiplied by itself. Remember, it's a square x times x. Expand this very, very carefully. 3 root 2 times 3 root 2 will be 9 times 2 is 18. Minus 2 will be 4. Minus 6 root 2 minus 6 root 2 will be minus 12 root 2 here. So 18 plus 4. Your final answer is 22 minus 12 root 2 units square. Don't forget, I left out units here. Okay? Are we good? Okay, next one. Total area of the 4 triangles, that will be easy. It's just length times breadth times 2, right? Of the 4 triangles, it's actually the area of 2 rectangles, which is 2 times length times breadth times 2. Okay, it's pretty easy. Expand this first. 3 plus root 2 times 5 minus 2 root 2. Very, very carefully. Multiply by 2. Okay, 3 times 5, 15. Root 2 times minus 2 root 2. Wait, let me see. Minus 2. Okay. Root 2 is 2. Minus 2 will be negative 4. Okay, this will be 5 root 2 and minus 6 root 2. When you simplify it, you have 15 minus 4 minus root 2 times 2. So answer is, inside here is 11 minus root 2 multiplied by 2. If they say exact value, it will be 2 bracket 11 minus root 2 unit square. If you can change it into decimals, 19.17 unit square. Okay, do follow, read your textbook for instructions carefully. Now, that's pretty easy, right? We found the area of the 4 rectangles. So area of the large square. Area of the large square will simply be h multiplied by h. H is actually your hypotenuse. You see, h is the hypotenuse. Basically, this big square has sides which is equivalent to the hypotenuse of the triangle A or triangle B. So all we have to do is find area of large square, which is h times h. We found here that the hypotenuse, okay, so what you have to do is you have to find the hypotenuse. The hypotenuse is just, okay, where I found area of large square. So what I do is I use Pythagoras theorem, which is h square. Okay, look at the triangle here. H square equals bracket 5 minus 2 root 2 bracket squared plus 3 plus root 2 bracket square. Using Pythagoras theorem, the hypotenuse square is the same as sum of squares of the other 2 shorter sides. So I've used it here. Expand very, very carefully. Okay, don't make mistakes here. And you find that h square is 44 minus 14 root 2, right? So area of the largest square. Now this is h square. Area of the largest square happens to be h square too. So you don't have to find h. The area of this big square is actually h times h. Area is h squared. So all you do is just express area of that h square is exactly this one. 44 minus 14 root 2, or if you change that to decimal, 24.2 unit squared. Okay, again, I forgot to write unit squared. Good. Okay, now a little bit more, take a deep breath. The last part, they say, last part of the question asks you to prove. Let's take a look at the question. Last part of the question, use the diagram to verify Pythagoras theorem. Use the diagram to verify Pythagoras theorem. So all I have to do is, okay, this is h, right? H, this is h. Let me use a different color. Basically, I have to prove that h squared plus h squared. Okay, let's see. Let's look at my beautiful drawing. Oops. Sorry, people. A little bit of light here.